In this lesson we're going to look at how to evaluate square roots. Let's start off with the radical symbol, and we know that square root of 25 is 5, the square root of 81 is 9, so every time you see the radical symbol you are trying to figure out what number this is the second power of, or what is this the square of, what root did it come from. And the radical symbol always represents a positive answer, positive number. For example, we know that negative 3 times negative 3 is 9, but we would never say that the square root of 9 is negative 3. So it has to not only be a number to the second power that gives us what's under the radical, but it has to be the positive version of that, or the absolute value of that number. So the square root of 9 is positive 3. Anytime you see the radical, it's going to give you a positive answer. And if you put a negative in front of it, then you can have the negative part. If you want the negative square root, you have to put a negative symbol in front of the radical. Now, if you have a negative underneath the radical, that number does not exist. Square root of negative 4 does not exist, because 2 times 2 is 4, and negative 2 times negative 2 is also 4. There's no way to multiply a number times itself and get a negative answer. That's why we can't have something like this going on. No way to square a number and get a negative answer. So anytime we see square root of negative x, for right now, we are simply going to say that that is not a real number. Now let's look at square root of 36 plus 64. So the lesson here is that you don't need to be taking the square root of individual terms under the radical. You always need to simplify under the radical before you evaluate the square root. So here we'll have to add first. 36 plus 64 is 100, and the square root of 100 is 10. So let's look at another one where we really need to evaluate first the square root of negative 5 squared. So if you square negative 5, you're going to get positive 25, and the square root of positive 25 is 5. And let's do a couple more here. I've got several for us. So the first one, square root of 36 is 6. And for the next one, the negative square root of 49 is negative 7. See, the square root of 49 itself is 7, but the negative is just sitting there in front. On this one, square root of negative 25, the negative is under the radical, and we can't have that, so this is not a real number. Here on square root of 25 minus 16, we have to do that subtraction before we can decide what the result is. So 25 minus 16 is 9, and the square root of 9 is 3. And here, square root of negative 13 squared would give us positive 169, but then the square root of 169 is 13. So you may have noticed here, look at this one and this one, and you may have noticed that when we come out to the end, it's really just the same number we started with, but it's been turned positive. It's the same base, but it's positive. And that's because a square and a square root cancel each other out. So the shortcut is that the square root of a square number leaves the absolute value of that number. So we know the square root of 6 squared is 36, which is 6. And the square root of 9 squared is the square root of 81, which is 9. So as long as the base is positive, it stays the same. Whatever the base is, that stays the same. If you use a negative base, like I have here, the square root of negative 4 squared, then it's going to come out positive. Now that we've seen several of these worked out, you may feel that you no longer need this middle step. You may feel that you could look at square root of anything squared and know that the anything comes out here. And I hope you will take advantage of that and skip this middle step now that you see how it works.